Good morning, everyone. So it's true. As I mentioned last Friday, we probably is gonna have a school tomorrow, like an in-person school tomorrow. Instead of that, we're gonna try to do it remotely, or like we're gonna learn it online, whatever. Um, just just keep in mind the next couple days is gonna be like really snowy, really icy. So please stay warm and stay safe. Okay. Um, Talking about a lesson today, I'm not gonna ask you to go to Schoologies. I'm not gonna ask you to like do any exit tickets on Schoologies. Instead of that, if you could like at home, if you could find a piece of paper and just listen to me through during the videos. Um, take note, write out the example, and turn it in. It should be good. All right. So okay, so the lessons of today is just like we gonna learn about the lesson of today is we gonna learn about the last two law of exponents, right? But before we get into it, I think it's gonna be better if I remind you a little bit about what we learned last Friday. Because 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 even though I'm not gonna give you an S ticket on Schoology, you still have to work. You still have to work on some problems at the end of the day. All right. So last week we learned like last Friday, like last Thursday, we learned about three laws. Right. The first one is what we call the products rule, which is we're saying that if you multiply two exponent with the same base, if you don't remember, like the big number right here, we're gonna call them base, and then the little numbers at the on the right corner, we are calling it power or exponents. All right, and now going back with the rule. What does it say? It says that if you multiply two exponents with the same base, you simply gonna do what? You gonna keep the base and then you add the exponent together. So let's give us an example. We're gonna have what? We're gonna have 2 to the power of 3 multiply 2 to the power of 5. So as as you can see, they have the same base too. So they have the same base. So what you're gonna do in here, you're gonna keep the base, and for the exponent, you just do what? You just add them together to get the final answer. All right. And not like another example is gonna be like if you have x to the power of 7, and then you multiply it to x to the power of 5. Again, for both of them, we have the same base x. So we keep the base x and then we add the exponents. That's it. Now, let's go to the quotient rule. You could think about like the quotient rules is the opposites of the product rule. Because in here, what did it say? It says that if you are dividing two exponents with the same base, you just simply keep the base, but you gonna subtract the exponent. But keep in mind, please, the order of the subtraction is that we're gonna take the exponents on top, and then we subtract it by the exponents we have at the bottom. You're not gonna go backward, all right? You're not gonna go upward. You're gonna go with the order from the top to the bottom. So let's say if you have maybe 5 to the power of 7 divided by 5 square. Again, we have the same base, which is 5. And we take the power. we subtract them together. All right, that's it. So like later today, might be like later today, is you're gonna see some kind of problems such as um let's say such as you're gonna have two exponents multiplied together on top, and you have something that you are dividing at the bottom. So how, how are you going to work on it? So for example, let's say if you have x to the power of 5 times x to the power of 3, and everything divided by x to the power of 6, something like that. So if you have a combination like this, the first thing I want you to do is please simplify whatever you have on top first. Please simplify this one first. So you cannot do anything if you have separate or like multiple exponents, right? Try to combine them into one single exponent on top first, and then you do, and then you divide them. You dividing them. So now, and because of that, first step, this one, like the x to the power of 6 stay the same. But I'm gonna what? Combine. I'm gonna combine those two exponents. So it's give me what? X to the power of a. And then after I already simplify the top one, and in this case, as you can see, we only have one exponent on top and one exponent at the bottom. That's the terms that we're going to try to dividing the exponent. So let's see. We have x and x stay the same. So we have the same base, right? And the exponents, because we are dividing, we're gonna subtract them, and which give us the answer x squared. That's how you're gonna handle that's how you're gonna handle them. All right. The last rules, like the last rules that we learned the last rule we learned last week was the power. What did it say? If you have one power inside the parentheses and another power outside of the parentheses, what you're gonna do is that you're gonna multiply the exponent together, right? Not plus, not minus. We're gonna multiply them together. So let's say, for example, you have x to the power of 3 multiplied by and the inside parentheses, and the power 2 is outside of the parentheses. What you do is just simply multiply. Take the exponents outside, take the exponents outside of the parenthesis and multiply it to every single exponents you have between the parentheses. So in this case, we only have one power, right? We only have one exponents between parentheses. So our exponent is going to be x to the power of 6. However, let's say that if we have like multiple, let's say that if we have multiple term, like we have something we have something like this. Let's say we have multiple variables, we have multiple exponents between the parentheses. If you remember what I says that we're gonna take the exponents outside and we multiply it to every single exponents we have inside, which means I'm gonna take the phi outside and I multiply that phi with every single exponent I have for x, y, and z. So the x will become x to the power 3 times phi times y to the power 5 times phi with the z to the power of 10 times phi. And our final answers will become x to the power of 15 times y to the power of 25 times z to the power of 50. All right. So yeah, so after after this one, hopefully, like if you haven't finished the extra tickets on from last Thursday, you could like these reviews are not for you to go back and finish them, right? So now, like today's we only have two things to talk about: the zero power rules and the negative rule. All right. So let's go to the first one, the zero power rule, or like the rules of the exponent zero or zero exponents whatever. Okay. So if you can see right here, the rule says that any exponent, any exponents with the any exponents with exponent zero, sorry, any term, any terms, any number, any terms, any variable, anything with the exponent zero will be equal 1, no matter what. Which mean it doesn't matter what numbers or like what variables or like anything that you get. If you have the power zero, you could it will automatically turn to 1. So here, if you have x to the power of 0, it will automatically turn to 1. You have 5 to the power of 0, it will automatically turn to 1. You have uh you have 1,000 to the power of 0. It's also turn to 1. Okay, so as let me repeat, it doesn't matter what power, what numbers you have, what variables you have. If if that variables have the power 0, it will automatically equal to 1. Or you could think about like you could automatically turn that term into 1. All right. Now let's look at this example. So you could do this one multiple ways. I don't really know like which way is gonna work best for you, but this is how I'm gonna handle these two equation, these two problems. All right. So the first one we have 2 times 6 to the power of 0 to the power of 2, right? So again, we have one power outside and some exponent inside, right? Let me remind you. If you have a numbers or like if you have anything without a power, that power or like the exponents gonna be 1. So now how I'm gonna simplify this one or like how I'm gonna solve this one. Again, I'm gonna distribute the power outside into every exponents I have inside. So this one turned to 2 to the power of 1 times 2, multiply to 6 to the power of like 0 times 2. And of course, you have to simplify it, right? Now, this will give you what 2 square times 6 to the power of 0. But we just say that this one will be this one will turn to 1. So our final answer is going to be 2 square times 1, or simply 4. Okay, you see that? Yeah, so it's just that the like the zero exponents rules just say that if anything anytime you have something with the power 0, it's automatically equal to 1. All right. And then here, so similarly for the second problem, I'm still distribute the 0 into between the parentheses. All right. So what we have 2 to the power 2 times 0 on top, 3 to the power 4 times zeros at the bottom. So 3 to the power of 0, 3 to the power of 0. And because that we have the power of zeros on both on top and at the bottom. So the exponents on top turn to 1, and same with the exponents at the bottom. So 1 divided by 1 will give you 1 at the end. Okay. Um um you know what? I'm gonna go through this one quickly. Okay, so now you have the 4 outsides, right? So first of all, temporarily I'm gonna ignore the 4. The first thing I'm gonna do, I'm gonna distribute the power 0 inside. So what do I have? 6 to the power of 0 times 5 to the power of 0 times 7 to the power of 0. Please remember, everything multiplied by 0 will be 0. So this one turned to what? 4 times 1 times 1 times 1. 6 to the power of 0 turned to 1. 5 to the power of 0 turned to 1. And 7 to the power of 0 turned to 1. So final answer is going to be 4. All right. So now, and the last problem might be some of you could go ahead and then just solve this one, and then all like you could skip you could skip to the other part of the videos. So the next one, what I'm gonna do first is I'm gonna distribute the power outside of the parentheses into the parentheses. So I'm gonna have 2 to the power of 0 times x to the power of 14. And what do I have? 2 to the power of 0 we turn to 1, and x to the power of 14 remain the same. So my final answer is going to be x to the power of 14. Okay, so yeah, the zero exponents rules, it's really easy. Just so basically if you already understand how to work with the product rules, the quotient rules, and especially the power rules, you you like yeah you take you probably already know how to solve the problems to solve the problem with the power 0. Okay. All right, the next one, and my next one, and might be the last part of today, the properties of negative exponents. So if you look right here, that's the rules. So some of you, if you're lucky or unlucky, in the last essay tickets, you already see some questions such as x to the power of -3, 2 to the power of -3, or something like that. And then sorry, and then some of you might not realize, but the answers you put down right there is not the final, and then it's not the correct answers we're looking for. But because last week we haven't learned the negative exponents, so I just let you just wrote down what you thought. This week after we already learned about the negative exponent, I'm gonna say I'm gonna have maybe some other rules about writing down those exponents. So now, if you can see, if you have a negative exponent such as x to the power of negative a is right here, what you gonna do is like you just flip it over. So you just flip it down to the denominator. You just simply you flip that exponent to like to the denominator and take away the negative side. So that's it. So basically, if you could read right here, the negative exponents basically just flip the part, like flip the exponent, flip that term, flip that number, flip the number with the negative exponent to the bottom part of the fraction, and that's it. Or like to the other side of the fraction part. That's it. All right. So yeah. So please write it down, and and after that we could do what? And after that we could take a look at those symbols. Okay. For this example, I'm gonna just ask you that I don't want to see those negative exponents. I want all the exponents, like all the final answers, only contains the positive exponents, which means you have to use the negative rule to get rid, like you must use the negative law, like you must have the laws of the negative exponents to get rid of those negative sides. And how you gonna do it? It's really easy. So please remember, anytime you see a negative exponent, whatever you need to do is that you make it, like you flip it down, like you flip it, you flip it to the bottoms of the fraction. So now you're gonna make a fraction. The top one is always one, and then for that exponent, just bring it down here and take the negative sides away. That's it. That's It's literally everything you need to do. So if again, if you have a negative exponent, put down here, put the one on top, and take the negative sides away. That's it. So similarly, you have a negative size right here. Put it down here. Put it below the line. Put it at the bottoms of the fraction. Take away the negative signs and put one on top of that. And then if you want to simplify it, fine. 3 squared 3 squared gonna give you 27. All right. Similarly, this one, oh, I have a negative size, right? I want to simplify it. How? I put it at the I put it down at the bottoms of the fraction. Put the one on top of that and simplify it. 9 squared gonna give me 81. Okay? So and let's say let's say that you have more than one term. Really easy. Simplify this one first. So I see that they are multiplying to each other's, right? So I'm gonna use the products rule. I'm gonna add the exponent first. So the base 5 stay the same. 3 plus negative 6 will give me 5 to the power of negative 3. And then to simplify the fraction, sorry, to simplify the negative side, I put it at the bottom of the fraction, take away the negative sides, and then put the one on top. My last step's gonna be try to figure out what's 5 cubed equal to. In this case, it's equal 125. It's just that easy. All right, everyone. So the problem below gonna be like you could use all of them to practice, but when you turn in your notes for today, please include at least 5 problems on your note, and each of them is gonna worth like 2 points for your essay ticket. If you got all 5 problems correct, you're gonna get like 10 points as usual. All right. Bye.